All right. Hello, ladies and gentlemen, and today we're working on solving two-step equations. I know you've been waiting for this all year. Well, here it is. So we've been talking about solving one-step equations. We have been solving equations similar to this. 3x equals 12, where we said divide both sides by 3, and I almost forgot my reflection line. I remembered it at the last minute. And we also decided when we see an equation like this, we should ask ourselves, what are we trying to find? We're trying to find x, so how do we get rid of everything else with it? Well, since this is what 3x is equal, they equal 12, we want to know what 1x equals. If we divide by 3, we get a 1 right there. A 1 times x is our x. The 12 divided by 3 is 4, which is our answer. And then on each of those, we took the time to check our work, go back to the original, and put in the value now, put in the answer we think is correct. 12 is equal to 3 times 4. So, confidence us. Be more confident, smiley face. There you go. We also looked at equations that dealt with addition or subtraction. So we might have the equation 9, let me start out with a variable instead. Y minus 9 equals 11. And similar to what we did with the multiplication and division, we would start with our line, our reflection line. Whatever I do on one side, divide by 3, I do on the other. Divide by 3. Figure out what you want at the end. You want y by itself. And then figure out how to get there. What's the opposite of subtracting 9? That would be to add 9. If you add 9, where you're subtracting 9, cancel out. Remembering the reflection line, whatever I do on one, I have to do on the other. So now I have 11 plus 9 is 20. And my final is to, again, check my work. See if this looks right. Does 20 minus, not minus y, but does 20 minus 9 equal 11? Yes, 20 minus 9 is 11, and I can feel confident. So that's what we've done up to this point. We've been working on these one-step equations. As you might imagine, when you see this title, two-step equations, we are going to combine what we've been doing. We're going to look at problems that include both some multiplying and dividing, or not multiplying and dividing, but multiplying and adding, or multiplying and subtracting, or possibly dividing and subtracting, or dividing and adding. So let's take a look at a real-world link, and it's going to walk us through the process. And I know sometimes I talk fast. Maybe it's because I'm so excited about this. If I do, just go ahead. If you need to replay it again, feel free to replay it. I'll try to catch myself if I'm going too fast, and I'll slow down some. So here we go, balloons. A company charges $2 for each balloon in an arrangement and a $3 delivery fee. You have $9 to spend. The equation 2x plus 3 equals 9, where x is the number of balloons, represents the situation. Work backward to solve for x. So take a moment to look at this. Pause the video and take a look and see if you could figure out what is going to go in these first 3 boxes. All right, so pause it and then turn it back on. Okay, so we're back. Start with the amount of money you have to spend. According to the problem, I have $9 to spend. Subtract the delivery fee. Yeah, they're going to take that delivery fee out regardless. What's left? Oh, you know what? I put the wrong thing in there. That's not what I should put. I should subtract the delivery fee. So minus 3 would leave me $6. Since each balloon is $2, divide by 2. I would divide that by 2, and I can afford to buy 3 balloons. Okay, now that I know I'm going to have 3 balloons, let's check our work see whether 3 balloons is a reasonable answer, a correct answer. If I if I spend $2 on 3 balloons, that's $6. Plus I pay my $3 delivery fee, that's $9. Yes, 3 balloons is my correct answer. I can feel confident about that. So now let's take a look at a second one. How many balloons could you have purchased if the delivery charge was only $1? So go ahead, pause things for a moment, and then work that out. Turn it back on, we'll check. Okay, so I have $9 to spend still. That amount hasn't changed. I'm going to take away $1 for the delivery fee. That's going to leave me $8. I'm still paying $2 per balloon, so I'm still dividing by 2, and that's going to give me 4 balloons. That's what I think I can buy. Let me see if that's true by checking my work. If I have $2 each for 4 balloons and add my $1 delivery charge, will that be the $9? Well, 4 balloons at $2 each would be $8, plus $1 for the delivery charge. Yes, indeed. I'm still spending my $9. I'm still happy with my answer. Okay, let's take a look at the next page. So this page starts with a really good graphic that ties in order of operations to what we're doing. If we were solving this problem, if we were solving the problem 2 times 5 plus 3, order of operations would say multiply by the 5 first, then add the 3, 13. Would you go ahead and label this? This is the answer. And these next 2 steps are the check. So if I want to check, notice I'm working backwards from my answer. I'm subtracting the 3. That's the opposite of this adding 3 right here. That's canceling that out. Then I'm dividing by 5. That dividing by 5 is canceling the times 5 out. So let's go back and circle each of the things that cancels out. When I'm at my answer and I subtract 3, that cancels out when I added 3. Now I'm to a point where I've taken that away, so now I'd be at 10, 13 take away 3. Then I divide by 5, which is the opposite of when I multiplied by 5, and I would be back at 2. So when we look at a 2-step equation, we're talking about an equation like 2x plus 3 equals 9 that has 2 different operations. In the case of this, it has multiplying, because 2x means 2 times x, and addition, because we're adding 3. So when we're undoing, we undo the addition or subtraction first. That's the opposite of order of operations. When you have order of operations, you do the addition or subtraction last. So when we solve, we undo it first. So here we go. Let's take a look at a problem. 2x plus 3 equals 9. I'm going to go back to this example, and I'm going to put my dashed line all the way through it. So whatever I do on this side, I do on this side. So step 1, I'm going to undo this addition. I'm going to subtract. That's going to cancel out. Those 2 are going to cancel each other out. I'm going to do the same thing over here. Now what's left on this side is the 2x. That's what remained. And on this side, the 9 minus 3 is 6. This is 2 times x. I'm going to do the opposite. I'm going to undo the multiplication by dividing by 2. I'm going to divide by 2 here, and then I have to do it on the other side also. And I'm going to get to 3 as my answer. I'm going to plug that in my check. It's going to get me down to a solution of 3 being correct, because when I checked it, I got 9 equals 9. And as soon as I have that, I can feel like I did this right. All right, so again, if you need to pause and review that, go ahead and do that. When you're ready, turn the video back on and we're going to the next page. So here is another set of examples. Here's an example that you're doing the same thing again. You're multiplying and adding. So to undo, you're subtracting and dividing. And then we have an example where we're multiplying -2 times y and we're subtracting. So to undo, we're doing the opposite. We're adding the 7. That undoes the subtract 7. And we're dividing by -2, the coefficient, which undoes the multiplication. And again, if you put this in your book, you will remind yourself whatever you do on one side, you do on the other. Number 4 is a little different kind of problem because in number 4, they're doing a problem that has a coefficient that is a fraction. We haven't talked about that. I purposely skipped over that lesson for right now. And so we're going to focus in on the ones that have whole numbers. Then we'll come back to doing those. But the process would be the same. Again, we've got that line. Again, the thing we were adding 4 to this, so we have to subtract the 4. And here, we're actually multiplying by 1/5. The opposite would be to multiply by 5. Again, we didn't talk about that yet, but we will. So would you go ahead and would you do problem A, problem B, problem D, and problem E? Do those 4 problems and then turn the video back on and we'll go through solutions. All right, so we're going to go through the solutions, and what I would recommend is look at the first one. We're going to solve A. If you did A correctly, then watch the solution for B. If you didn't do A correctly, figure out what you did wrong and then redo B and D and E. If you need more space, you can do them in your spirals. You will definitely need some room to do these. You're going to have a hard time fitting them in the math book. So on A, when I look at problem A, 2x plus 4 equals 10. If I was putting a number in here, let's just say I was sticking a value in. I didn't know the answer. Let's just, down here, let's just say I had 2x plus 4, and I said x is going to be 5. And so I did 2 times 5 plus 4. I would do the 2 times 5 first and get 10 plus 4, and that would give me my answer 14. So the last thing I would have done was the add 4. Same thing here. The last thing would be the add 4. So the first thing I undo is the add 4 by taking 4 away on each side. When I take that 4 away, I'm canceling out right there where I added 4, which means I'm going to have 2x and it's going to equal 6. Now, if I had extended my line down, I should have done this. If I had extended my line and put x equals at the very bottom, since x is the thing we're trying to find, this is the unknown. That's what we're trying to discover, is what's the value of the x. So now I have 2x's equals 6. Well, I don't want 2x's, I want 1x. Notice we multiplied by 2 here, so to undo it, we're going to divide by 2. When I divide by 2, 2x divided by 2, this creates a 1. 1 times x is x. Great, I've got the x I want by itself. And 6 divided by 2 is 3. Then I would go ahead, I would check my work. And to check my work, I would say, is 2 times 3 plus 4 equal to 10? Well, 2 times 3 is 6. And 6 plus 4, yes, that is equal to 10. 10 is equal to 10, and I can feel good about my answer. So if you had that problem right and you want to just watch me go through the next 3 solutions, go for that. If you didn't have it right, though, would you please pause the video and take a moment to revisit your work on B, see if you can figure out what you should have done differently. All right, I am going to go ahead I'm figuring you're back after pausing to redo any work you needed to do. I'm going to go ahead and I'm going to solve B. And my solution method is going to look similar. I'm going to have my reflection line. I'm going to bring it down a little further this time. This time I'm going to come all the way to the bottom. X equals. I know that's my goal. So the first thing I need to undo is adding 5. I'm going to undo it by subtracting 5. That is going to cancel out. Boom. And it's going to leave me 3 x's over here. I'm on my way to getting x by itself. Over here, 14 take away 5 is going to leave me 9. Next, I'm going to divide by 3. When I divide by 3, I get a 1 right here. That's great, because 1 times x is x. That's what I want. And I get a 3 right here. So I'm saying x is 3. Looks like 3 is a popular value for x here. So I'm going to check that work by saying, does 3 times 3 plus 5 equal 14? Well, 3 times 3 is 9. 9 plus 5, yes, that is 14. If I could just successfully write 14 on the screen here. There it is, 14. So 14 equals 14, and yay us. All right, I'm going to need to spread out my work here a little bit. Probably what I need to do is take my completed answers and just move them off to the side a little, so I have room to keep working. So let me just grab these and put them off to the side here a little bit and bring over problem D. So problem D, no surprise, solution's going to start out the same. There is my line. Here is the x that I'm going to get as my answer. The first thing I'm going to undo is this adding of 5, so I'm going to take 5 away on both of those. This is going to cancel out. Bye-bye. That leaves me 4x equal to 13 take away 5 is 8. I'm going to undo the divide by 4 because I was multiplying by 4 here. 4x is 4 times x. So now I'm going to divide by 4. That's going to give me a 1 right there. So 4 divided by 4 is 1 times x is the x I want. 8 divided by 4 is 2. When I check my work, I end up with 4 times 2 plus 5. Is that 13? Well, that's 8 plus 5. And yes, 8 plus 5 is 13. Yay for us. All right, last one. All right, last one. Now you'll notice this one's different than the previous 3 because in this one, our coefficient is -5. That doesn't change anything in what we do. It just means we need to keep track of that negative. So let's go ahead, and we know S is what we're solving for. S is the unknown. So we have plus 8. We're going to take away 8 to cancel that out. That's the opposite. So these cancel. Plus 8 minus 8 cancels out, which means that we've got 5s left, negative 5s left here. We have -2 take away 8. If I was thinking of that problem, if I was thinking of -2 take away 8, I would probably change that to -2 plus -8. That's just, it's easier for me to see that problem. I'm going to have -10 here. This is -5 times s. If I'm going to undo it, I have to divide by -5. Be careful. A common mistake is just to divide by 5. You have to divide by exactly what the coefficient is. So I'm going to divide by the -5 on each side, and -5s divided by -5 is s. -10 divided by -5, +2. When the signs are the same, answer will always be positive. I can now check my work to see if I like what this looks like. Is -5 times 2 plus 8 equal to -2? Well, -5 times 2 is -10 plus 8, -2. And -10 plus 8 will create 8 zero pairs. So 8 positives cancel out 8 of the negatives, which means 2 of the negatives are left, which is exactly what I needed. So if you need to, go back and look through those problems again. This is the fundamental idea behind solving two-step equations. All right, let's jump back into the book. And we went ahead and finished those. So let's take a look at the next batch. And we're given a problem here that is a word problem. Toya had her birthday party at the movies. It cost $27 for pizza and $8.50 per friend for tickets. Now, just to give you a little more information here, this cost doesn't change by the number of kids, right? The 27 is the same. If 10 kids show up or 2 kids show up, same $27. If only 2 kids, if Toya just decides not to invite anybody but her bestie, they get to split all that pizza themselves. If 9 other kids show up, then the 10 kids, Toya and her 9 friends, have to split the pizza. But the 27 doesn't change. The $8.50 does. The $8.50 is only charged for each friend that shows up. So if we go down, by the way, they spent $78. So if we look at cost of pizza, which does not change based on friends, plus cost of a friend, for one it would be $8.50 because that's the per means 1, times the number of friends gives us 78. So then we would do this just like we did before. Notice once we've written this, we're back to doing what we did before. Take $27 away from both sides. We're at $8.50, n equals 51. Divide by the $8.50, divide by the per ticket price, and that tells you that 6 friends can show up to the party. All right, would you please go ahead and do problem 1, problem 2, problem 4, and then turn the video back on. Okay, so let's discuss the answers to these 3. So in each case, I know that I'm going to, if I'm doing an equation, I'm going to get these both set up. I'm using that reflection line, and I'm figuring out what's coming to the bottom. In this case, s is the variable. I'm going to end up with s. Over here, y is the variable. I'm going to end up with y equals something. So my first step here is to undo this 1, get rid of the 1. So I'm going to take 1 away from each side. When I do that, these cancel out, and I end up with 13 minus 1 is 12, and 12 equals 4s. I'm going to bring my s down a little bit, give myself some room to work. Then I'm going to undo the multiplication. When I undo the multiplication, that turns into the number 1. So I've got 1 times s would be s. There we go. And when I divide the 12 by 4, 12 divided by 4 would be 3. And then I check that work. Does 13 equal 1 plus 4 times 3. So does 13 equal 1 plus 12? Notice now I'm doing order of operations. And yes, 13 equals 13. I like that answer. Next problem, same idea. The first thing I'm going to do is I'm going to undo the minus 5. The last thing I did, if I was solving it, the last thing I would do is subtract 5, so that's the first thing I'm going to undo. That's going to cancel. That's my goal, is to get that to cancel out so that I have just the negative 3y left. 10 and 5, 15. Looks like I need to move those. I'll put them down toward the bottom when I do these in the future, I think. So what's left? Well, negative 3 is being multiplied by y. So I'm going to divide by negative 3, which gives me a 1 right there. And 1 times y gives me y. The 15 divided by negative 3. 15 divided by 3 is 5. These have different signs. So basically I'm saying if I had 15 and I divided it into groups of negative 3, I would have negative 5 groups. So if the signs are different, 15 and negative 3, positive and negative, my answer is going to be negative. And then, to check my work, I'm going to have negative 3 times negative 5 minus 5. Will that equal 10? Well, negative 3 times negative 5 is positive 15. Notice it's a positive 15 right there. You'll notice as you undo these, or as you check them, see that 12 is that 12. So 15 minus 5 is 10. And yes, 10 equals 10. Baby, we're done. All right, last one, number 4. So reader wants to buy some CDs that cost $14 and a DVD that costs $23. Buy some CDs. So we know we got more than one there. She has $65. Write and solve an equation to find out how many CDs she can buy. So our equation is going to be the sum CDs, we don't know how many. Let's just call those C as a variable for CD. Each cost $14. So $14 times some number of CDs plus the 23 for the DVD can total the 65 she has to spend. So my equation is 14C plus 23 equals 65. Notice as soon as I convert that from a word problem to an equation, I can go ahead and use the same steps I used above. I'm going to take away the $23. I'm going to take out the price of the DVD so I can get down to just what the CDs cost. So when I take that out, I've got the CDs left at $14 each, and my 65 take away the 23 is 42. So I know that I've got $42 to spend on CDs, and the CDs cost $14 a piece. So I'm going to divide by the cost of the CDs so I can figure out how many CDs I can get. So my single CD then, 42 divided by 14 is 3. And if you need to, you can do this right here. 42 divided by 14. I'm not sure how much long division helps in this case because you're just doing some guessing. So what you might want to do instead is say, all right, if I buy 2 CDs, that's $28 total. What if I add a third CD? So what if I add another 14? And that's where you can see it's $42. So 3 CDs, so my solution is 3 CDs. But wait, before I say I'm going to say that, before I walk away, I'm going to check my work. Does 14 times 3 plus 23 equal 65? Well, we just did 14 times 3 over here. That was 42. And yes, if you add 42 to 23, 42, and 20 more is 62, and 3 more is 65, I can feel confident about that. Yay me. Now I'm going to go home and listen to my CDs. I hope at least one of them is Linkin Park. All right, so there's yourself ready to go. You got a lesson to do. Let's talk here about what you're going to have for homework problems on this lesson. So for homework, go ahead and let's take a look at the next page. Come on, flip over. So for homework, I'd like you to do problem 1, problem 2, problem 3, 4, and 5. You saw this on the agenda. Problem 7, so you're going to take this idea of the bar and use it to solve. I'd like you to do problem 9. Then, if you could flip a couple pages over, skip these extra practice for now, I'd like you to do 24 and 25. I'm going to come back to 24 here in just a moment. And then 27, 29, and 31. Now let's talk about problem number 24. So with problem number 24, what you're going to do is you're going to use these to fill in these spaces, not this space. This is the answer. This is going to be some number of tickets. But you're going to use these to fill in these. Now you'll notice there are only 5 here, and there are 7 here. So you won't use them all. You'll figure out which ones to fill in across. And then you'll end up with how many tickets Craig can purchase. All right, I think you're going to be successful on this. If you've finished the video and gotten this far and there's class time left, jump in and start working on homework. All right? Be sure you come back to class with whatever questions you have about doing this work.